If you rely exclusively on your Web3 wallet to tell you what happened to your money, you are flying blind. Wallets are designed to be user-friendly. They summarize, they simplify, and in the complex cross-chain environment of 2026, they frequently lie by omission. When a transaction fails, when a token doesn't arrive, or when you suspect a decentralized exchange routed your trade poorly, the customer support department does not exist. The only objective source of truth is the blockchain itself. To read that truth, you must master the Blockchain Explorer. This guide breaks down the anatomy of EVM explorers like Etherscan and BscScan, explains the massive architectural shift required to read Solana's Solscan, and shows you exactly how to trace complex DeFi routing that your wallet hides from you. The ultimate ledger: why explorers matter. A blockchain is just a globally synchronized database. A block explorer is simply a search engine built on top of that database. It indexes every single state change, every token transfer, and every smart contract deployment, presenting it in a readable web interface. In 2026, the market is broadly divided into two architectural camps: the Ethereum virtual machine, EVM ecosystem, and high-speed parallel networks like Solana. Because their underlying architectures are fundamentally different, you cannot read their explorers the same way. We will start with the EVM standard. The EVM standard, Etherscan, and BscScan Etherscan is the gold standard of block explorers. Because Binance Smart Chain, BNB Chain, Arbitrum, Base, and Polygon all use the EVM architecture, their explorers, like BscScan, Arbitrum, and BaseScan, are virtually identical clones of Etherscan. If you know how to read one, you know how to read them all. When you paste a transaction hash, TX hash, into Etherscan, you are looking at the receipt. The basic fields are obvious: the status, success or revert, the block number, and the timestamp. But beginners instantly get confused by the from and to fields. If you swap USDC for Chainlink on Uniswap, the to field does not show the address of the person who sold you the Chainlink. The to field shows the address of the Uniswap smart contract router. In DeFi, you are almost always interacting with a piece of code, not a peer. Zero-value trap and token transfers. The most common panic-inducing moment for a beginner is looking at the value field of a transaction and seeing 0 ETH, even though they just spent $10,000. In the EVM, the value field only tracks the native gas token of the network, ETH on Ethereum, BNB on BscScan. It does not track smart contract tokens like USDC, USDT, or standard altcoins, ERC20s, or BEP20s. To see where your $10,000 went, you must look at the tokens transferred section. This is the most critical part of the receipt. It shows the exact chronological flow of assets. If you executed a complex swap, you will see your USDC leave your wallet, enter a liquidity pool, and the corresponding altcoin leave the pool and enter your wallet. If the tokens transferred section shows your assets leaving but nothing coming back, you have either interacted with a malicious contract or your trade was entirely eaten by a high slippage sandwich attack. Internal transactions and the logs. Sometimes, the tokens transferred section doesn't tell the whole story, especially when dealing with complex aggregators or automated yield vaults. To see the true plumbing of the blockchain, you must click on the Internal TXNs and Logs tabs. Internal transactions occur when a smart contract triggers another smart contract to move native ETH, or BNB. These transfers do not show up on the main transaction ledger because they weren't initiated by a human wallet. If you withdraw ETH from a staking protocol and it doesn't show up in your main wallet history, you must check your address's Internal TXNs tab. That is where the smart contract's payout is recorded. Logs are the raw, unfiltered data emitted by the smart contract. As we discussed in our analytics guide, this is what professional indexers read. If a transaction behaves strangely, the logs will show exactly which mathematical parameters the contract executed. While they look like heavy hexadecimal code, modern Etherscan interfaces decode them into readable tables, showing exact token decimals and liquidity pool state changes. BscScan nuances, wrapped assets, and bridges. While BscScan looks exactly like Etherscan, the context of the network is different. BNB chain is highly optimized for low fees, which makes it a massive hub for retail trading and, consequently, sophisticated scams. When reading BscScan, you must be hyper-aware of wrapped and pegged assets. If you hold ETH on the Binance Smart Chain, you do not actually hold Ethereum. You hold a BEP20 token issued by a bridge, often Binance itself, that represents a claim on ETH locked on the main Ethereum network. When investigating a token on BscScan, always click the token tracker link. Check the total supply and the contract creator. Scammers frequently deploy fake tokens named USDC or Ethereum on BNB chain. The block explorer will faithfully display the name the scammer typed in. The only way to verify you hold the real pegged asset is to match the smart contract address against the official Binance documentation. The paradigm shift: Solscan and parallel execution. If you take your EVM knowledge and apply it to Solana, you will be completely lost. Solana does not use the EVM. It uses an entirely different architecture optimized for parallel execution. Therefore, its primary explorer, Solscan, operates on different logic. In Solana, everything is an account. Your wallet is an account. A smart contract, called a program, is an account, and the data a program uses is stored in a separate data account. When you paste a transaction hash into Solscan, the first thing you notice is the absence of a simple from and to. Instead, you see a list of signers and instructions. The Instructions tab. Because Solana processes transactions in parallel, a single transaction is often a massive bundle of different actions called instructions. A single click in your Phantom wallet might generate a transaction with 15 different instructions, creating a token account, approving a delegation, routing through 3 different decentralized exchanges, and updating an Oracle price. To read a Solana transaction, you must scroll through these instructions chronologically. Token balance changes. This is the saving grace of Solscan. Because Solana transactions are so complex, Solscan provides a token balance change tab at the very top. Instead of forcing you to read the raw instructions, it calculates a simple before and after snapshot of your wallet. It explicitly shows your wallet lost 500 USDC and gained 10 SOL. In 2026, for daily trading verification on high-speed networks, this tab is your primary dashboard. Wallet forensics, tracking the whales. Beyond verifying your own trades, block explorers are the ultimate tools for market research and wallet forensics. If you want to know if a token is a good investment, you don't read Twitter, you read the Token's Holders tab on the Explorer. Are 80% of the tokens held by just 3 wallets? That is an immediate red flag for a rug pull. Is the largest holder a verified smart contract for a decentralized exchange liquidity pool? That is a sign of healthy trading infrastructure. You can click on any whale's wallet address and see their entire financial history. You can see when they bought, what decentralized exchanges they use, and whether they are currently moving millions of dollars in stablecoins to centralized exchanges, a classic signal that they are preparing to aggressively buy or sell. In Web3, privacy is an illusion, but transparency is absolute. Every player's hand is visible on the table, provided you know how to read the cards. Conclusion: a block explorer is not just a receipt viewer, it is your X-ray vision into the decentralized economy. Whether you are deciphering an internal transaction on Etherscan, verifying a pegged asset on BscScan, or untangling a 15-instruction routing path on Solscan, this is the foundational skill of self-custody.